Welcome to 7th in the series of videos on the history of current electricity. In this video, we're going to understand the microscopic view, the evolution of our understanding of electricity from late 1800s to early 1900s. It all starts with the famous experiments of cathode ray tube experiment of J.J. Thompson, the father, the senior. Incidentally, J.J. Thompson Sr. and Jr. are both Nobel laureates. J.J. Thompson Sr. Was awarded Nobel Prize for finding out about the cathode ray tube experiment and discovery of electrons. And his son was awarded Nobel Prize for the discovery that electrons exhibit wave nature. But that's an interesting snippet. So in his cathode ray experiment, he found out electrons, and he basically found out the E by M ratio and or the charge per mass ratio of electrons. And around the similar timelines, which is late 1800s, Paul, Karl, Ludwig, Drude, he used Newtonian and statistical mechanics to talk about, to verify Ohm's law, which is a macroscopic law from microscopic theory. So in his theory, he hypothesized that the electrons are moving randomly and they hit the positive charge, which is like a large block in crystal ions. So as they move, they keep hitting these blocks, and he uses theory to calculate the resistance in terms of material properties, and he also used the theory to find out about Ohm's law, which is basically a macroscopic law from microscopic view. And usually whole of physics is like that. You have a macroscopic observation, and then you come up with a microscopic theory to prove your macroscopic observation. And in about 1911, Rutherford had established a lab, and in his lab there were two young his apprentice or interns called Geiger and Marsden, who did this famous alpha particle experiment. In this alpha particle experiment, they used a source which is a radioactive element, and which was emitting alpha particle, which is nothing but helium ion, He2+, that's alpha particle without an electron. And as they pass through very thin gold foil, probably 1 atoms or few atoms thick, what they realized is for every 100,000 particles which hit the detector on this side, that means that pass through the gold foil, 1 reflects back. So there's 1 in 100,000. So from this, Rutherford concluded his famous Rutherford model, which is, you have in the center of the nucleus, and you have electrons orbiting around the nucleus. And the size of this nucleus the size of the atom is of the order of 1:100,000. So they basically establish that most of atom is empty space. So this is a ratio of the radius of the atom to size of the nucleus, right? Which is radius of the nucleus. So radius of the nucleus to the radius of the atom would be equal to 1:100,000. Niels Bhor extended Rutherford's model to where he talked about fixed orbits, electrons moving in fixed orbits, and as they fall down from higher orbit to lower orbit, they emit electromagnetic radiation, which is the reason why we see color. And he explained why atoms like hydrogen, when they are ionized, hydrogen lamp or sodium lamp, etc., where in the hydrogen gas there's electricity that goes by that emits particular spectrum. So you can imagine that this is nothing but a minor extension of, or not a minor but a major extension of Rutherford model, keeping his fundamental principle of electron moving around the nucleus same. Finally, here is a view of the old theory and the modern understanding. So it all started with Benjamin Franklin, who used the convention of using plus for something where it has a higher fluid, electric fluid, and minus, which is a lesser electric fluid. And he mentioned that the current, the so-called current, it moves from higher fluid to the lower fluid. So current, the idea of current and the fluid theory was probably much older than our modern understanding of current. For that reason, we kept the idea of current flow and positive and negative terminal all same for historical reason. But today we know that the reason why the bulb glows is because there is an electric field that is established, so which is an electric field due to the excess of the positive protons. These are protons. So the plus that Benjamin Franklin imagined and the plus here, this with a circle, are two different things. This is what Benjamin Franklin imagined. This is what reality is. So these are, in this end, due to chemical reaction, you have a lot of atoms which are positive ions without electrons on building up, and they put up an electric field, and due to the electric field, all the electrons get pulled against the electric field. So electrons are getting pulled towards a positive. And that is why we say the current flows in the opposite direction of the flow of electron. It's important to understand why certain things are there, like one of them is the current flow opposing electron flow. And the true reason is due to historical context. It's too difficult to change this convention after about 100 years of using it. So I hope you enjoyed this series of video of macro view and micro view of current electricity. I'll see you in the next set of videos on your theory of current electricity. Until then, see you. Take care. Bye.